A reference frame is a physical concept related to an observer and observer's state of motion, or basically, how you view the world. We conduct an experiment that, depending on your reference frame, two very different things occur. We're going to break down those two reference frames and show you that's not the case. Now here's it again in case you missed it.
In my frame of reference, I see the tennis ball travel in a parabolic curve as Timmy throws the tennis ball up. This is because from my reference frame, I'm at rest, or my velocity is 0 meters per second. So I see Timmy, the car, and the tennis ball moving at a constant 10 miles per hour, or about 4.5 meters per second. This is why you can see the tennis ball fall back into the sunroof, because the horizontal and vertical velocities are independent.
My frame of reference was different than Kat's. While she saw a ball traveling in a parabolic curve, what I saw was in fact very different. Because I was moving along with the car at a speed of 4.5 meters per second, velocity. What I saw was when I tossed the ball up, it appeared to go straight up and then come straight back down. This is because the tennis ball was also going at the same velocity. When I look back out at Catherine, who's filming, I see her moving at negative 4.5 meters per second. That is because from my view, I'm not moving and everything around me is. The reason we use reference frames is it allows us to look at problems in a different light and potentially solve them in an easier method. For example, one way of doing this is in a collision, you can look at where the center of mass travels and travel along with that center of mass. And therefore, you eliminate a variable and you are able to conserve momentum and have an easier method to solve that problem.